Welcome everyone. Today we are going to look under the hood of something you use every day, AI assistants like ChatGPT and Cursor. Most people use these tools but have no idea what's actually happening behind the scenes. So by the end of this session you will. We are going to cover 9 sections today. Each one is a building block. Think of it like learning how a car works, its engine, transmission, brakes. Each part makes sense on its own. But the real insight comes when you see how they all work together. So, the eight components. The eight components. So, over here, the eight components we will cover over here are conversational memory, RAG pipelines, vector database, AI agents, tool calling, AI gateway, model routing, and streaming. And in the last section, we will see exactly how ChatGPT and Cursor plug all of these together in a real product. So let's begin. Now, the first question we need to answer is, how does an AI remember what you said 2 messages ago? It doesn't have a brain, it doesn't have a memory the way you do. So, what's actually happening? That's what section 1 is about. That is the conversation memory. The conversation memory. Now, think of memory, think of think of memory like your WhatsApp chat history, like WhatsApp chat history. Now, there are two kinds of memory. One is short term and another one is long term. Now, short term memory is what you remember from today's conversation. Long term memory is your entire chat history, okay, that you can scroll back to. Now, without memory, every message you send is like texting a stranger who has never met you before. So, long story short, conversation memory allows an AI assistant to maintain, maintain context. Okay. So, conversation memory allows an AI assistant to maintain context across turns in a conversation. Now, there are two distinct layers to it. There are two distinct layers to it. One is short term in context, another is long term persistent. Now, this short term in context memory is the current conversation stored in the LLM's context window and is limited to the model's token limit, that is 128k tokens, that is in GPT 4o. Now you will ask me, Saurabh, what is this context window? What is this context window? Okay, so context window is the maximum amount of text an LLM can read and work with at one time. That is your question, the conversation history, and any documents all combined. Think of it as the model's short term memory. Once it's full, older content gets pushed out. Gets pushed out. The another layer is this long term persistent. That is facts, preferences, and past interactions stored in a database. Database, if I say database, I mean Redis or Postgres SQL, and when relevant. Retrieved when relevant. Okay. Now the question is how it works. How it works. So let me explain you a bit in bit detail how it works. I hope my screen is visible. Okay. So if I say that user sends a message, okay, user sends a message, that is, the system fetches the recent turns. The system fetches the recent turns from the session store. From the session store. Then relevant long-term memories are retrieved. Then relevant long-term memories are retrieved via a semantic search from vector store. Via semantic search from vector store. Now, then after that what happens? Both are injected into a system prompt. Both are injected into a system prompt before sending it to the LLM. Before sending it to the LLM. Then LLM's response is stored back into the session store. Stored back response stored back to the session store and potentially the long term store and potentially the long term store. Okay, and potentially the long term store. So this was it, how it works. Now let's talk about some real world usage over here. Okay, real world usage over here. Now there are main three real world usages as we have seen. Okay, the first one if I talk about is this. What do you say? Uh, Chat GPT memory. So what Chat GPT memory does? It stores user facts across sessions, their names, preferences, ongoing projects in a knowledge graph. User can view, edit or disable it anytime. This is called ChatGPT memory. Then we know this cursor, this vibe coding platform. Okay. Now this vibe coding platform, it remembers the files you have opened. If you have used it, you must be aware about it, how it works. Your recent edits and the full full project context. Now there is this rule, that dot cursor rule file, you know, which is being created. It acts as a persistent long-term memory across every session. Across every session. Yeah. Across every session. Okay. Then there is what you called this enterprise AI. Okay. Now what this enterprise AI does, it remembers employee role, department, previous support tickets. It is role-based memory which ensures each user only sees context relevant to them, never another employee's data. Never another employee's data. Okay, never another employee's data. Okay, now let's get to the another section over here. Let's get to the another section over here, and that is RAG. That is RAG, Retrieval Augmented Generation. Okay, now in RAG, let's take an analogy over here. Imagine you are an open book exam student. You are an open book exam student. Now, without RAG, The LLM answers from memory alone without 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 RAG. Okay, yeah, I think it's working right. So without RAG, the LLM answers from memory alone, like a closed book exam. With RAG, with RAG, before answering, the system opens the relevant textbook chapters and hands them to the model. Okay, the model can now answer with up to date domain specific facts it was never trained on. And this is what RAG is. This is what RAG is. Let me repeat. With RAG, before answering, the system opens the relevant textbook chapters and hands them to the model. Okay. The model can answer with up to date domain specific facts it was never trained on. And this is what RAG is. This is what RAG is. So, moreover, moreover, the LLMs have a training cutoff. LLMs have a training cutoff. They do not know about the recent events or your private documents. Okay. Moreover, moreover, LLMs don't know about recent events and private documents. Okay. And second thing is that fine tuning is expensive. Second thing is that fine tuning is expensive and cannot be updated in real time. And cannot be updated in real time. But RAG, this RAG, that is retrieval augmented generation, it provides a cheap, scalable, always current knowledge layer with retraining. With retraining. Okay. Okay. Now let's come over here to this RAG pipeline. This RAG pipeline. Let's discuss this one. You will understand in detail, how it works. Now, if we focus on this particular part that is called ingest part. Okay. Now, if we just focus on this particular part that is called ingest. Now, what is happening in ingest is that documents such as PDFs, web pages, code, databases are loaded and split into chunks. Split into chunks. Then each chunk is converted into a vector using an embedding model. Using an embedding model. For example, text embedding 3. Okay. Now, these vectors are stored in a vector database such as Pinecone, Quadrant, PG vector. Now, this then comes this, the query. Now, in this, user's question is embedded using the same model. Let me give you an example of it. It would be more clearer if I give you an example of it. Uh, Let me give you an example of it. Let's come over here. Let's come over here. Now, what is happening over here? We are talking about the query, the user's question. See, when you or a user type a question, okay, type a question, it goes through the same embedding model. It goes through the same embedding model that was used to embed all the documents. That was in step 2. That was in step 2. This embed. Okay. So your question also gets converted into a vector. A vector is a what? A vector is a what? These are list of numbers representing its meaning. Representing its meaning. Okay. Now, both the documents and your question are converted using the same method. Okay, they are converted using the same method, that is embedding. They live in the same meaning space, so the vectors are directly comparable. They live in the same meaning space. Suppose this is a meaning space, so they are directly comparable. Now, what happens? Then the takes your question vector, system takes your question vector, okay, and searches the vector database. Searches the vector database for document chunks whose vectors are closest to it. Okay, here closest means the most similar in meaning. Most similar in meaning. Let me give you a very small example over here. Suppose you ask, what is the refund policy? What is the refund policy? Now, this question gets embedded into a vector. Embedded into a vector. The vector database searches and finds that the chunk from your PDF saying customers may return products within 30 days for a full refund. For a full refund. Now, this has the closest vector to your question. Closest vector to your question. Even though the words don't match exactly. Now, that chunk is then returned and passed to the LLM, or retrieved chunks are injected into the prompt as context. Come over here. Now, what is happening? This goes over here. Then these are injected, retrieved chunks into the prompt. Okay, chunks into the prompt. Then, then LLM, this LLM, okay, generates an answer grounded in the retrieve context. So the journey goes from here, from ingest to embed, embed to store, store to query. User's query is also embedded. Okay, the way documents are embedded, from query to augment, where retrieve chunks are injected into the prompt as context, and then to generate, where LLM generates an answer grounded in the retrieved context. Grounded in the retrieved context. Okay, so this was RAG pipeline. This was RAG pipeline. Now, there are some variants of RAG 2. There are some variants of RAG 2, naive RAG, advanced RAG, modular RAG, agentic RAG. Okay. Now, what is naive RAG? Naive RAG. Sorry about the way I pronounced. What is naive RAG? Now, this is the basic version. This is the basic version. You ask a question, it searches the database, grabs the top chunks, and then hands them to the LLM, and done. And done. So it works fine for a simple Q&A on a small document set, like a student who reads the first three relevant paragraphs and writes an answer and writes an answer. Then comes this one, and that is this advanced RAG. Now, advanced RAG is uh, it's a bit different. What happens before searching? It rewrites your question to be the clearer, to be clearer. After retrieving, it re-ranks the chunks to put the most relevant ones first, and then it also combines the keyword search and the semantic search for better results. Like a researcher who refine their search query and then sorts the results by relevance before reading. Before reading. Then we have this what is called modular RAG. This is production grade plugin architecture. Here each piece is a separate module here. You can upgrade just the retriever, that is the separate module, without touching the generator, again the separate module. For example, you have a car where you can replace the engine without rebuilding the whole vehicle. Okay. The next RAG after modular is the agentic one. Agentic one. Here the agent is in charge of the retrieval strategy itself. It decides it decides whether to retrieve at all, what to search for, and how many times to search. If the first retrieval isn't enough, it searches again with a different query, like a detective who keeps pulling new evidence until they have enough to solve the case. Until they have enough to solve the case. Let me give you a good example of this for like this comes under which category. So perplexity.com. Perplexity.com. It is essentially a RAG engine on top of the web search index. Okay. So Perplexity is closest to advanced RAG. Why? Think about it. Why it is closest to advanced RAG? Just give a thought about it. Okay. It is closest because it ranks the search result before injecting them into the prompt. It also has a flavor of agentic RAG. You know why? Because the system actively decides to trigger a web search every time rather than just querying a static vector database. So in short, an advanced RAG with agentic characteristics layered on top is what is perplexity.com. Is perplexity.com. Now let's move to another topic over here, the vector database. Okay, vector database. Now, traditional databases, they stores rows and columns. They stores rows and columns, such as you search with exact matches. You say where name is equal to John. Okay, where name is equal to John. On the other hand, on the other hand, on the other hand, this this vector database stores meaning. That is, you search with concepts, find me everything similar to the idea. Okay, like searching a library by a topic instead of an ISBN number. Okay, so it is more about meaning. Okay, it is more about meaning over here, not about the exact keyword type of a search. So this is the difference between traditional and vector database. So what is a vector over here? A vector is an embedding model that converts text into a list of numbers. Okay, vector is an embedding model that converts this text into a list of numbers typically this 7682307 dimensions. Moreover, it does semantic search. That is, semantic similar sentences produce vectors that are close together. Okay, see, interest, bank loan, fill in, kitten, cat. How this is done? Through a distance measured by cosine similarity. Okay, cosine similarity. So this is semantic space, right? So when a query comes in, it is embedded. When a query comes in, it is embedded, and then the vector database compares it against all the stored vectors to find the nearest matches, and then returns the original text linked to those closest vector. See, match chunks returned. Chunks returned. Okay. So this is what about vectors, right? And how they are converted into a text, and how the text, sorry, is converted into a list of numbers, right? Okay. Then there are some top vector databases. Let me go through this very briefly. Now, this Pinecone, Pinecone managed production grade serverless. So suppose you are building a new production app and don't want to manage infra. Okay, then in that case use Pinecone. That case use Pinecone because it is fully managed. You just call an API and no servers to maintain. Okay, then this comes VV8, that is open source multi-model built-in ML. Now, if you want open source and multi-model, that is text plus image, use VV8, and moreover it is flexible and not locked to one cloud vendor. Okay, it is not locked to one cloud vendor. Then is we have Quadrant. Okay, that is it is Rust based high performance payload filtering. So it is built specifically for fast metadata filtering alongside vector search. Okay, so this is what Quadrant best for. If I go for Milus, okay, if I go for Milus, then I would say it is basically built for massive scale enterprise deployments such as billions of vectors, and in that case go for Milus. Then we have PG vector. Okay, PG vector. So PG vector again can be used when you are already using PostgreSQL. Okay, so no, zero new infrastructure over here. Just add a column type and then you are done. Then you are done. Okay. Then last but not the least is sorry, no, we have one more. We have Chroma. So used for local development, sorry, and prototyping. In this case, no setup is required. It's just a simple throwaway friendly vector database. Then we have this Redis stack. Okay. Then we have this Redis stack. So in Redis stack, if you're already using Redis caching, then use Redis stack because just reuse what you have instead of adding a new system. Instead of adding a new system. Okay. So this was all about vector databases. Okay. Now let's jump on to the next segment over here. That is we have AI agents. Very interesting topic. But I'll give you briefly over here, not in detail, because this is the conceptual understanding that I want to make it clear. Uh, then we have agents, AI agents. Now, if you get into an analogy of it, a basic a basic LLM call, a basic LLM call is asking a librarian a question and they give you an answer. ChatGPT. You ask a question and you get an answer. But an AI agent is like hiring a research assistant. Is like hiring a research assistant who decides which books to look to, which books to look at. If I am comparing, taking an example of a library, LLM is like asking a librarian a question and getting you an answer. But in case of AI agent, it's like hiring a research assistant who decides which book to look at, runs multiple searches, reads the results, and asks follow up questions, and then hands you a complete report. So it is done all autonomously. It is done all autonomously. Okay. So, long story short, an agent is a system that uses an LLM as its reasoning engine, that uses an LLM as a reasoning engine, okay, and takes autonomous multi-step actions to achieve a goal. To achieve a goal, let's come to this core loop. Okay, let's come to this core loop. Now, if you see this observe over here, what do you mean by observe? What do you mean by observe? So it means receiving the current state, receiving the current states. That is user query, tool requests, and memory. Okay. Now from here, if we go to thinking part, that means the LLM reasons about what to do next. What to do next, such as chain of thought or react. That is more like a picking a next action. Then we come over here to act. Act means calling a tool or produce a final answer. Produce a final answer. Okay. Now, this loop then repeats. That is, it feeds the tool result back as context and continue until it is done. And continue until it is done. Okay. And continue until it is done. Now, let's come back to over here. Let's talk about some real world examples of AI agents. So, you know about cursor. You know what cursor. So, in agentic world, what exactly it is doing? What exactly it is doing over here? Any ideas? If you have been using cursor or Claude, you know, more of a cursor because these days we are installing Claude in Visual Code as well. But cursor is again a different kind of a model routing, software, I would say, where it handles both the simple queries and the complex queries in terms of codes. So, so a cursor is an agent that reads your code base, runs tests, edit files, and fixes bugs autonomously. This is what cursor does. Now we all do know ChatGPT now, but ChatGPT with tools is an agent that decides to search the web, run Python, or read a file. This is ChatGPT with tools. That is an agent. But this enterprise AI, this is a kind of an agent that reads the support ticket, queries the CRM, and drafts a response or creates a follow-up task in Jira or creates a follow-up task in Jira. Follow-up task in Jira. Okay. So this was all about AI agents. Now let's talk about another related topic to agents that is called tool calling. That is called tool calling. That is called tool calling. More of a function calling. Okay. Now over here, the LLM alone is a very now this LLM alone is a very smart brain with no hands. Smart brain with no hands. Okay. Tool calling, tool calling gives its hands. Okay. You define what tools exist, you define what tools exist, and the LLM decides which tool to pick. LLM decides which tool to pick, which inputs to send, and how to use the result. Okay, how to use the result. So, tool calling is the mechanism that lets an LLM act, not just talk about it. Okay, turning a model that can only generate text into one that can look things up, run code, and interact with real systems by calling predefined functions. Okay, let me explain you in a code how this tool calling works. How this tool calling works. See, I can say that it is more of a chef choosing which knife to use for which ingredient. Okay, you are just like giving it a brain, you can say, or hands. Okay, you'll understand with the code base. Okay, okay, over here at the top, over here at the top, we import OpenAI. Okay, that's the official Python SDK for talking to GPT models. And here we create client object using our API key. Using our API key. Now think of this client as the phone you will use to call the OpenAI. Every request go through this one object. Every request go through this one object. Now if you scroll down and come over here, that is, we're talking about tools here. Now here it's get very interesting. We are defining the tools. Okay, see this tool list. This is not a Python code that runs a function. This is a description written in JSON that you send to the LLM so it knows what tool exists. Okay, look at this get underscore weather. Get underscore weather. It has three things: a name, a description, and parameters. And parameters. Let me see if I can make my pen tablet work over here. No, it can't. Okay, parameters. Now, this name, this name, that's what comes back when the LLM wants to use it. Okay, uh, let me complete. You'll understand. If okay, this description, this is the most important part over here. The LLM reads this sentence to decide whether to call the tool or not. It never sees your actual Python function. Never sees your actual Python function. Then there are these parameters. It means what inputs does this tool need? Here it needs a city and optionally these units. Okay, let's read the description here. Returns the current weather for a given city. Use this tool whenever the user asks about the weather, temperature, rain, sunshine, or climate condition in a specific location. Do not use this tool for general knowledge questions unrelated to weather. So this is what description, and we're going to use this tool whenever the user asks about weather and temperature. Okay. Now a bit, if you can scroll down, come over here. Okay. This is actual Python function. This is actual Python function. Okay. Get weather and get city population. Now in a real app, these would call a live weather API or a database. Here we are using fake hard-coded data just so we can see the flow without needing external accounts. Okay. Now notice something important over here. The LLM never see these functions and it will never run them. Only your Python application runs them. The LLM only sees the JSON description we wrote above. LLM only sees the JSON description we wrote above. Okay. Now scroll down a bit more. Let me see. Okay, over here. Tool dispatcher. Now this executes this execute underscore tool function is your dispatcher. When the LLM says I want to call get underscore weather, get underscore weather with city Tokyo, with city Tokyo, this function receives that request, figures out which Python function to call, runs it, and returns the result as a string. This is also where you would put security checks, rate limiting, okay, logging and auditing, input validation. The LLM asks, but you decide what actually runs. What actually runs. Now, let's come over here to the main flow, all 6 steps in one function. Now, we are in the main function that is run tool calling demo. This is where all 6 steps happens in a sequence. This is where all 6 steps happens in a sequence. We we build a message that lists with the user's question and a call. Messages, we build messages that list with users' questions. Yeah. And call this client chat completions create. Now notice here we pass tools is equal to tools. Okay. That's us attaching our tool list to the request. Now every time we call the LLM, it gets to see what tools are available. What tools are available. After the call, we check this response dot choices 0 finish reason. If it says tools underscore calls, the LLM doesn't have enough information to answer yet. It wants to use tool first. It wants to use tool first. Now scroll down a bit more over here. This step 3. Now this is the most surprising part for the most people. The LLM does not answer the user's questions yet. Instead, it sends back the structured request, basically saying, before I can answer, please run get underscore weather with city is equal to Tokyo for me. With city is equal to Tokyo for me. We extract that from the assistant. We extract that from the assistant. That is assistant message dot tool calls. Now each tool call has a name, arguments, and an ID. Now a name means which tool to run, argument means the inputs as a JSON string, and ID is a unique tag so we can match the results back later again. Okay, that the LLM requested. Okay, now if you scroll a bit more over here towards here, the application executes the tool. Now your code takes over. Your code takes over. We loop through every tool call the LLM requested. parse the arguments with JSON.loads, and pass them to execute underscore tool. That function runs the actual Python function. Okay, runs the actual Python function and gives us back the result as a JSON string. So LLM is just sitting there waiting. It has no idea what's happening on your server right now. It asked and you are doing the work. And you are doing the work. Now if you scroll more over here, 267 code over here. Now we we send the tool results back to the LLM. Yeah, over here. We send the tool result back to the LLM. Okay. We append the assisting tools request to the message history and then add each result as a tool message linked to the original request using that ID. Then we call the LLM again. The second call is like saying, here are the results you asked for. Now please answer the query. If the LLM needs more tools, the loop runs again. Otherwise, otherwise, finish underscore reason becomes stop and we exit the loop. And we exit the loop. Now, the final one, the final step. Final step. Now, the LLM now has the real data, okay, from your tools. It writes a natural language response grounded in that data. We pull the text out of the response dot choices 0 message content here, okay, and print it. Now, this is the full cycle over here. This is the full cycle, how this web tooling works. Okay, how this tool calling works. This is the complete cycle over here. Now let me get back over here and let's talk about this, the common tools which are in AI Assistant. Okay, these common tools. Now I'll discuss all the important ones. We know web search, okay, code interpreter, REST API call, browser scrape, and we do have one more. It should be over here, which is not right. And there is also one important which is known as calendar. Okay, now this web search, this one, this is used by Perplexity, ChatGPT, and Gemini. So it fetches the real-time information. Okay, this tool web search. Now this code interpreter, this is used by ChatGPT Cursor. So basically it executes Python JSON in a sandbox. Then we have REST API call. This is used by any AI assistant with integrations with Slack, Jira, or Salesforce. Then we have this SQL query. Okay, so queries internal databases on users' behalf. It queries internal databases on users' behalf. Then we have browser and scrape. So again, it is used by Perplexity and web agents. So basically, it navigates and reads the web pages. Reads the web pages. Okay. Now this one is the calendar. It is used by Copilot and Gemini. It reads and writes calendar events. Reads and writes calendar events. Okay, calendar events. Now, another one important thing I would like to highlight over here because I did not showed you the output. Let me also show you the output. Maybe I run. See, this is the output. This was the question. The first one: what's the weather like Tokyo right now? So these are the two tools. Okay, get weather and get city population. But only this tool was called get weather. This was ignored. Okay, so after performing all the steps, the AI assistant response was the current weather in Tokyo is sunny with a temperature of 28 degrees C and humidity level of 60 degrees C. Okay. Then another question was what is 2 plus 2? Now we know there are only two tools that were called. So all the steps were skipped and the AI assistant gave us the final answer from LLM, that is 2 plus 2 equals 4. It didn't even call. So the final answer again wasn't from the tools. Okay. The another question was tell me about the current weather and the population of Mumbai. Now here in this particular case there are two tools. It called both the tools, get weather tool and the uh, get city population. So the response was the current weather in the Mumbai is 34 degrees C with a humid and hazy condition and the humidity level is at 20 degrees C. Now as for the population, Mumbai has approximately 20 million residents. Okay, you can say 20.6 million residents. Now another question was how many people live in London. Again, these two tools were called. No, sorry to interrupt about that. These two tools were called, but the focus was not on get weather. It this was ignored because the question was on how many people live in London. So get city population was the main tool that was called over here. So LLM returned one tool request. If I go over here, LLM returned two tool requests because two questions were asked. Okay, sorry, I'm just correcting my mistake over here. Now we were talking about London, right? So this tool was called in this particular case, and the assistant got the answer. Assistant gave the answer. The estimate population of London is approximately 9.6 million people. So this is the way it works. Okay, but the important part that I would like to tell you over here is that now see over here, no tool was called because this was out of the way question. What is 2 plus 2? Okay, here LLM returned two tool request. Here, no tool request was returned. But the most important question is that the key insight which I want to talk about is that there are critical skills in writing a good tool descriptions. Writing a good descriptions. Okay. Writing good tool descriptions. Okay. The LLM decides which tool to use based on purely on reading your description. So if there are if there are vague descriptions that can lead to wrong tool choices. If there are precise descriptions that can lead to correct tool choices. Correct tool choices. This is one of the most important insight that I wanted to talk. Okay. Most important insight that I wanted to talk. Okay. Now let's continue with the another section that is AI gateway. That is AI gateway. Yeah. So think of an AI gateway. Think of the AI gateway exactly like an API gateway. Think of this, yeah, think of this AI gateway exactly like an API gateway, but specifically built for LLM traffic. But it is specifically built for an LLM traffic. Now, just as an API gateway sits in front of your microservices and handles auth, rate limiting, and routing, an AI gateway sits in front of your LLM. This AI gateway sits in front of your LLM, okay, and adds intelligence. It knows about tokens, models, costs, and prompts. This is the difference between AI gateway and the API gateway. So what an AI gateway does is it validates API keys. It validates API keys or JWT tokens before any LLM call is made. Before any LLM call is made. Then, in rate limiting, it prevents abuse, limits call per user, per team, or per end point. Okay. Then this model routing. What it does, it sends requests to the right provider. OpenAI, Anthropic, Google, based on rules. Then comes this cost tracking. Then comes this cost tracking. So cost tracking, what it does, it tracks token usage and cost per user, per team, per project. Per user, per team, per project. Then we have prompt logging. Prompt logging captures every request and response for audit and debugging. Then we have caching. Caching returns cached responses for identical or near identical prompts. That is, it saves cost. Then we have this fallback. Okay. If OpenAI is down, then automatically retry with Anthropic or self-hosted models or self-hosted models. Then there are some popular AI gateways. There are some popular AI gateways. One of the most popular gateway is Light LLM, okay, which is open source, open AI compatible APIs, and 100 plus LLM providers are over there. Then we have Kong AI gateway. What it does, it extends Kong API gateway with LLM specific plugins. Then there are custom gateways also, in which many large companies build their own on top of Nginx plus Redis. Nginx plus Redis. So this was all about AI gateway. Now let's get into another section, that is model routing. Model routing. Now in model routing, it is like choosing the right vehicle for a journey. Now you would not take a Ferrari on a dirt road, or you would not take a bicycle on a motorway. Okay. In the same way, simple queries gets cheap with the help of models like Haiku or GPT-4 Mini, and the complex reasoning gets expensive with the powerful models like Claude Opus and Sonnet. Now think about this way in this regard. Okay, we have over here quick quick Q&A, summarize text, classy, intent. So it is routed towards simple routine work. Okay, less number of tokens. Okay, latency is 500 milliseconds. Model for these are Haiku from Cloud and GPT-4 Mini. So simple queries are routed towards these models. Now, if there is something like, I would say edit code file or analyze report. So like this is a medium kind of query, not very complex, not very simple. Okay. So tokens are less than 32K, latency is less than 3 seconds. So it goes to Sonnet, okay, 4.6 or GPT-4o. Okay. Now, if you come over here with a multi-step plan, deep research kind of a means that is a complex reasoning, tokens are higher, latency is like, quite very much. Then you go with Opus kind of a model. or these are not relevant. Most of them are merged with GPT 5.5. Okay, then if you see the cost over there is increasing, see, $0.003. So it's going, basically, it should be like this, but if I go from here, it is increasing in this direction. It is increasing in this direction. Okay, so the cost is increasing in this direction. Okay, so this is all about model routing. Then there are some routing strategies that one can take. Okay, one is the rule based routing. That means if task type is code, use Claude Sonnet. Use Claude Sonnet. And if it is image, then use, now there are more better, GPT 5.5, GPT 5.5. Okay. Then there are cost based models. That is cost based routing. Sorry, not models. Cost based routing. So route to the cheapest model. Route to the cheapest model that can handle the request. That can handle the request. Okay. Yeah. Right. Yeah. Right. See, route to the cheapest model that can handle the request, like Haiku. Then we have latency based models, latency based routing. I don't know why I'm saying models. Latency based routing. So it routes to the fastest responding model, you know, less of a latency. If I talk about less of a latency again, you have GPT-4o Mini or Haiku. GPT-4o Mini or Haiku. And these are useful for real time chat. Then you have quality based routing. So if evaluating model performance on your specific task, then route accordingly. Then route accordingly. Then we have canary routing. It means send 5% of traffic to a new model to test it before a full rollout. To test it before a full rollout. Then we have a again fallback routing, as I discussed previously. If primary model fails, automatically retry with the secondary one. Okay, retry with the secondary one. Then we have got economics of this model routing. Claude Opus for complex reasoning, multi-step problems, nuanced writing. GPT-4 Mini and Haiku, simple Q&R classification, summaries, faster response. Then there are some self-hosted for high volume, cost-sensitive, private data. So like if cost is very high through OpenAI and Anthropic models, then you can have your own self-hosted models. And if there is a privacy issue with your data, you might not be willing to give your data to these kind of organizations. Then you can again use your self-hosted models and you can get trained those models on your private data. It's much more again cheaper also, and also your data is protected. Then there are some specialized models, that is codestral vision embedding. Okay. Embedding. Right. Okay. Now let me give you a real world example over here of a cursor. Real world example of a cursor. Oh, it's not working that way. Anyways, let's try this only. Yeah, cursor. So the cursor routes request. If we are talking about model routing, right? So cursor routes request based on the task type. Its routes request based on the task type. So for simple autocomplete, for simple autocomplete, okay, it uses fast cheap model like Haiku, right? For full file edits, it uses Claude. it uses Claude Sonnet. And again, for complex multi-file refactors, it uses Claude Opus. So this tiered routing reduces the cost by 60 to 80%, which is compared to using the most powerful model for everything. So, like if I compare the most powerful model with this cheap model, or the strategy of the routing of tiered routing of this cursor, then it save cost up to by 60 to 80% compared with the powerful models. Okay, compared with the powerful models. Let's get into the next section over here. I know, see, these are very important concepts in terms of the modern AI assistant. Very important concepts. Now, let's talk about streaming responses. This is very interesting. This is related to how ChatGPT gives you response. Now, if you come over here and think that, take an analogy, see, without streaming, if you ask the AI a question, it is like sending a text message and waiting 30 seconds for the full reply to arrive all at once. But with streaming, it is like watching someone type in real time. You see each word as it is generated. This is why ChatGPT feels fast. This is why ChatGPT feels feels fast, even when generating long responses. You must have observed, right? Even when generating long responses. ChatGPT always feels fast. We wait for the response comes and it's typing one word by word. So it feels very fast, but in actually it is not. But it's not a boring GUI. So why streaming matters? Why streaming matters? This matters because LLM generates token one at a time. LLM generates token one at a time. Streaming lets you show each token as it is produced. There's no waiting. Without streaming, users see nothing for several seconds. So that's kind of a poor, UX, poor UX. But with streaming, time to first byte can be under 200 milliseconds, even before long responses. Even before long responses. Streaming also lets the front end interrupt. It also lets the front end interrupt the response if needed. That is the stop button. That is the stop button. Okay. Uh, let's discuss about something about streaming technologies and when they should be used. So these are some of the streaming technologies: SSE, WebSocket, gRPC streaming, HTTP, chunk and it. Now SSE server, that is server sent events. Server sent events. This is the simplest option. This is one-way stream from server to browser. That is HTTP native. Okay, WebSocket, when to use WebSocket is like it's bidirectional, that is better for real-time collaboration. Cursor and live coding. Cursor and live coding. gRPC streaming, why, when it should be used? When you're doing something high performance and it's used in backend to backend communication. Something related to high performance and used in backend to backend communication. Then this is the lowest level, used by some custom streaming implementations. This let's talk this in a bit detail now. SSE. See, in this SSE, that is server sent events, the server keeps talking and the browser just listens. It's one way only, server to browser, and it is built directly into HTTP, so no special setup is needed. And this is what powers the word by word typing effect in Chat GPT. Now, this WebSocket is a two-way phone call instead of a one-way announcement. Both the browser and the server can send messages to each other at any time, because this is bidirectional and in real time. Needed when the user is also sending data back continuously, like cursor showing, like I'm sorry for that, like cursor showing live cursor positions when multiple people edit together. Okay, that is WebSocket. Then this gRPC streaming. It is built for speed between two servers. We are talking about backend to backend communication. So it is built for a speed between two servers, not for browsers. And it is used when one backend service needs to stream data to another backend service very efficiently. Okay. For example, your AI gateway streaming tokens from the LLM provider before passing them onto the user facing server. Okay. Crystal clear. Then HTTP chunked. As I said, this is the lowest level manual kind of an approach. Instead of sending one complete response, the server sends response in small pieces, that is, in chunks, okay, as they become ready. So SEC is actually built on top of this, that is HTTP chunked. So this is more of a foundation than something you would choose directly. Choose directly. So implementation note, I would say in OpenAI stream is equal to true. Okay. So, like all major LLM APIs support streaming, like OpenAI Stream, Anthropic does it, Google in LangChain uses .stream instead of invoke. So, you know, these big platforms, they all use streaming. Okay. Now, now how these real platforms like ChatGPT, Cursor, okay, you know, these combine these components. Okay. How they combine all of these components. Now that you understand each component individually, right? Now let us see how this ChatGPT and Cursor, okay, connect them all into one production system. Connect them into all into one production system. Okay, let's come over here first on ChatGPT architecture. Okay, let's discuss about this. Now, whether you are on a website, mobile, okay, or any app, or you are using an API. Okay, every request hits a load balancer that spreads the traffic across servers so nothing gets overwhelmed. Now, in Gateway, OpenAI's own front door. This is OpenAI's own front door. It checks your API key or login and limits how many requests you can make based on your planned tier, free versus paid. In free, you can make, I think, many requests, but again, they are limited. In paid, you have more requests. Okay. Then this here comes model routing. Now it picks the right brain for the right job. GPT 5.4 mini or nano for quick and simple quick and simple replies. GPT 5.5, 5.4 for complex and reasoning tasks. Okay. Then we have memory. If you have turned it on, ChatGPT remembers facts about you across about different conversations, your job, preferences, ongoing projects, which is stored as a structured knowledge graph, which is stored as a structured knowledge graph. Okay. Yeah. Yeah. So which is stored as a structured knowledge graph, rather than raw chat logs. Okay. Then comes agents and tools. So ChatGPT isn't just a text generation. Isn't just a text generation. It can search the web, run the Python code, and generate images. It's not Delhi now. 5.5 does a very well job. Right. Generate images with ChatGPT images. Okay. And reads an uploaded file. That is file analysis. Then we have over here that is called rack. Okay. Now, when you build a custom GPT and upload documents, those get broken into chunks and stored so the GPT can pull the relevant pieces when answering. Okay. This is rack. Whenever you have seen, whenever you upload documents, okay, so that broken into chunks, okay, and stored so that GPT can pull the relevant pieces. So we have discussed about rack. Then, last but not the least, no, we have another thing also right over streaming. Again, use SSE, here SSE, which is why you see words appear one by one instead of waiting for the full answer, right? But, but, anything that comes after but is very important. Hmm, keep in mind. But behind the scenes, OpenAI constantly evaluates model quality, tests for safety issues, that is called red teaming, okay, and manages which model version is live and manages which model version is live. That is model versioning. Okay. Now let's come over here to the cursor architecture, the hottest coding platform these days, which is known as vibe coding. Let's talk about this. So entry entry is like, we can say, the cursor. From entry standpoint, from entry layer, we say cursor is a desktop app. Okay, and every AI request you make goes from the app to the cursor's own backend server. Own backend server. Okay, and by Electron, I mean it is built on Electron. Okay, gateway. See, cursor doesn't host its own models. It doesn't host its own models. It's a gateway forwards your request to either Anthropic or OpenAI behind the scenes. Then there is model routing. Okay, model routing. Haiku is basically used for fast autocomplete suggestions. Sonnet 4.6 we can say for regular code edits, and Opus 4.7 is for big refactors across many files, again for complex refactors. Then we have memory. Now, instead of chat memory, Cursor treats your entire open project as context. And a special .cursor rules file lets you set permanent instructions. It should always follow. It should always follow. These days, it is with Claude else also. There is some, I remember dot Claude file something. No, it's dot Claude. Yeah. Same way, it's dot cursor rules. So those are Claude rules. These are cursor rules. Now comes the next one that is called rack. So Cursor indexes your whole code base into embeddings. So when you ask a question, it retrieves the most relevant file functions automatically. Let me repeat. Just listen to it properly. Don't miss it. Cursor indexes your whole code base into embeddings. So when you ask a question, it retrieves the most relevant files functions automatically. Then comes agent and tools. Here, the composer agent can read your files, run terminal commands, and edit multiple files in one go. Not just suggest code, but actually act on your project. If you have used cursor, you'll come to know what is going on if you are using the cursor. Then comes the streaming part. As the AI generates code, you see a live diff preview updating in real time inside your editor. Okay. Then you have LLM ops. Cursor tracks how to use it, that is, which model, how often, what worked, to keep improving its routing decisions over time. Okay. Over time. Improve routing and model selections. Okay. So this was about how ChatGPT and Cursor use all the components. Okay. Or you can say that how real platforms, how real platforms combine these components. Okay. Combine these components. Right. Okay. Now let's join this all together in this summary. As this one is the final slide, as this one is the final slide, and the goal here is to make everything click together. So by now you have seen each of these 8 components in isolation, but the real world insight is this, that every AI assistant you use daily is just these same 8 boxes: conversational memory, rack pipelines, vector DB, AI agents, tool calling, AI gateway, model routing, streaming. Okay, so let's go through one by one briefly. Okay, on these one more time. So, conversation memory is how AI remembers what you said. Start simple as a buffer, scales up to a knowledge graph. Rack pipeline, on the other hand, is how the AI reads your documents. Ingest, embed, store, retrieve, inject into prompt, and generate. Vector DB is a search engine that makes RAG possible. Not keyword search, meaning based similarity search. Then AI agents. How the AI takes actions on your behalf. This is what AI agents. It observes, thinks, acts, and loops until the job is done. Then we have tool calling. How the AI talks to the outside world. The APIs, databases, calculators. It requests your per executes. If you remember, I showed you an example about the weather of Tokyo and population of London. You know, It was going to the weather tool. It was going to the get population tool. Okay. AI gateway. This is a traffic cop. Handles auth, rate limits, cost tracking, caching, and fallback. And then comes the model routing, the brain that picks the right model. For simple, cheap queries, it selects the model, uh, cheapest model, you know, for example, Haiku. Or for complex reasoning, it selects models based on complex reasoning, like Opus, Sonnet. Then the streaming part. Why ChatGPT feels instant? You typed a question and you get a response. Just feel instant. Token arrive one by one rather than waiting for the full response. Okay. So this is it. This is it. I hope you liked the lecture and you know I've given you an overview of how these 8 components work. The real time examples also, how this chat GPT and cursor use all these components. And I hope you like this lecture and the session that I have taken. And if you have any questions or any queries, you know, you can ping me, directly reach me. I'll be available. And I'll be making more such kind of knowledgeable videos. So let you know how the world of AI is working and moving ahead and how things are shaping up in the industry. So thank you very much. Have a nice day and happy learning.